Oh, you are being recorded right now. So power standard 10, I can't statement 1, I can graph a linear function. This is where we left off yesterday. When we talk about linear functions, we talk about an equation. The equation of a line that you need to memorize is y equals mx plus b. This is called slope intercept form. This is the foundation to all equations. Next year, when you all go to Mrs. Z, September 7th, this is where you're going to start. Slope intercept. And now I expect you not to remember this. Okay? I don't expect you to go to Ms. Z next year and she goes, all right, we're going to talk about slope intercept form, y equals mx plus b. And you go, oh yeah, I'm a master at it. Let's go. I expect you to say, ooh, I don't remember this. I remember that crazy 6th-hour 7th grade math teacher, who was my favorite, talking to me about it last spring. And then when she starts to go over those things, when she starts to go over the material, I do expect you to say, oh yeah, I remember that. Oh yeah, I kind of remember that now. Oh yeah, I remember that crazy guy doing that last year. That's what I expect. I don't expect you to come in September and be a master at this. But I do recommend, or I do require you to be familiar with it next year. Because next year, this is what you start with. Slope intercept. That's the foundation. Then Miss Z is going to build on that with point slope, standard form, parabolas, hyperbolas, inverse function, exponential function, growth and decay, absolute value function. And if you can't comprehend slope intercept, those other 6 or 7 I just gave you, kumbaya, sayonara, avita jane, ciao. I'm saying goodbye and you're saying aloha. Aloha means hello. Does it? It's a country. Now, the reason why this form is called slope intercept is because you are given in the equation the slope and the intercept. Now, Mr. Meeks, for the past 2 days, you've been talking about the y-intercept. Is there an x-intercept? There is an x-intercept. That's in 8th grade. Okay? You'll also talk about perpendicular lines, parallel lines. You will be graphing perpendicular lines. You will be graphing parallel lines. Not this year. If you can graph a line, that's all we need you to do. Okay? What does slope mean? Slope is the steepness of the line. The bigger the slope, the steeper the line. The smaller the slope, the less steep the line will be. And remember, when you think of slope, I really want you to think of and concentrate on that phrase, unit rate. Because that's technically what it is. 50 miles per hour. 6 watermelon seeds per slice. 8 gallons of water lost per cannonball. It's a big guy or girl. That's what I want you to think of. When you hear unit rate, think of slope. When you think of slope, hear slope, think of unit rate. And again, it's how steep the line is. The bigger the slope, the steeper it gets. Now, the y-intercept is where the line crosses the y-axis. And it can cross the y-axis anywhere. 0, 2, -2. It could cross the y-axis at -3.5. It could cross the y-axis at positive 4.25. So, to start where we left off yesterday, this is for those of you that missed class due to the NWEA, we kind of just brushed upon this. And then we decided to graph some of these lines. And the first example I gave, or I'm going to give today, is y equals -2x. Now this is called a coordinate plane. Both axes have arrows. Both axes are labeled either X or Y. The horizontal axis is X. The vertical axis is Y. Notice there are 4 sections. Each section is numbered. This is referred to quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. They're called quadrants. Quad meaning 4. You have 4 sections. Looking at the equation y equals -2x, we need to determine where is this line going to start? Where is the y-intercept? Where will the line cross the y-axis at, Jacob? 0 is correct. There is no number added to x. There is no number subtracted from x. Therefore, this line will pass through 0. And what do we call 0, Josh? The origin. Now, I gave you a couple problems yesterday, Josh, during SAT. Did you ever do those? Yeah. All right. You need to see me tomorrow and show me them. All right. Now, our slope is -2. How do we write -2 as a unit rate, Kayla?
-2 over 1.
Very good. Now, our vertical change is -2. So, Zach Durham, if our vertical change is negative, do I go up 2 or down 2? Down 2. Timmy, my horizontal change is 1, and that's positive. So do I go to the left 1 or to the right 1? Very good. And then you simply connect the dots. Now to take this one step further, and I'm actually probably going to take this 2 and 3 steps further. What if I told you that x was negative 2? What would y be? Alyssa? 4 is correct. What if I told you x is 1? X is 1. What would y be? Angelina? What if I told you x was 3? X is 3. Brina? Possibly negative 6. Exactly negative 6. Now to throw a curveball at you, what if I told you y is 30? The value of y is 30. What's x, Jake? Negative 15 is correct. Now watch this. Each one of these points should be, better be, on this line. Negative 2, 4. And it is on that line. 1, negative 2. 1, negative 2. It's on the line. The point 3, negative 6 should be on this line. And if I extend my line, look what happens. It's on my line. So every point that you are given, in other words, if I tell you what the value of x is and you figure out what y is and vice versa, it better be on that line. If it's not, you did something wrong. Because all of these have to be a straight line. What's the slope from this point to that point? What's the slope from that point to that point? Aubrey? Negative 2. Well, what about if I go from this point to this point? What's that slope? Timmy? Negative 2. Christina, you ready for the tricky one? The real hard one? What's the slope from this point all the way to that point? What's its slope? Negative 2. Because all those points are on that line, it doesn't matter what point you choose. If you go from point to point, the slope is going to be negative 2. Because that's what the equation says. And it's even take this one step further. What's the difference between these 2 points? What's the difference here? You guys remember what difference means, right? What does difference mean, Layla? You were shaking your head, yes, I figured you knew. To subtract. Very good. Whew. My goodness. What's the difference between these 2 points? I mean, you all have calculators if you can't do it in your head, for the love of God. Kenzie? Okay. Timmy? Ooh. The difference? Difference, Layla said to subtract. Kat? Yes, negative 4. And what's the difference between these 2 points? Gerard? 2. Now, let's go back to the unit rate. The change in the vertical axis divided by the change in the horizontal axis, the rise over the run. Do you remember me singing the song Y over X? Did I do that for this class? No? The Y over X. Y goes in the numerator, X goes in the denominator, Y over X. So, watch what happens. If I take the Y value, which is -4, that is the change. That is the difference in the Y values. And I divide that by the change or the difference in the X values. Notice what I get. What's -4 divided by 2? What is it? -2. What about these two? 4 and 30. What's the difference between 4 and 30? Angelina? 26. 30 minus 4 is 26. Now, what's the difference between -2 and 15? Nate? 7.5. Oh my God. Oh God. Oh jeez almighty, have mercy. If you're listening to this on YouTube, I need a raise, and this is why I need a raise. The difference between 15 and 2 is not 7.5. Zach. Oh, Jesus. Kylie. Oh, for the love of God. You guys have calculators. Why are you not typing this in? Aaron. Oh, for the love of God. Pat. -13. -15. For everybody out in YouTube land. -15. Difference of -2. Oh, there it is. There it is. So now, we take the Y value, we take the change in the Y value, and we divide that by the change in the X value. And what's 26 divided by -13? -2. Everything you do has to be -2 for this problem. All right, so for our second linear function, we have y equals 5/6 x minus 1. We need to determine our starting position, which is our y-intercept. It's where the line crosses the y-axis. Veronica, what do you think? 0. Do you know why? Why would you choose 0? Not sure? Okay. Sebastian. Where do you think our line is going to start? Pass through the y-axis at? What location? -1 is the correct answer. Nice job. It's right here. There's our y-intercept. It's being subtracted from x. Now, the nice thing about number 2 is that our slope is already written in fraction form. We already have our unit rate, 5/6. It's in fraction form. So our change in our vertical axis is 5. And it's positive. So are we going to go up or down, Maddie? Up. 1, 2, 3, 4, 5. Our horizontal change is positive 6. Are we going to go left or 0? Or left or 0? Left or right? Jason. Correct. 1, 2, 3, 4, 5, 6. Connect the dots. Now, some people ask me, Mr. Meeks, how do you get such a straight line? Well, I have very good hand-eye coordination. I was in the 99th percentile for hand-eye coordination on my IQ test. So that's why my lines are so straight. I will be giving you a ruler for your tests and for your worksheets and study guides. Okay? I don't need a ruler just because I'm in the 99th percentile. Kylie. It's okay.
Well, you can use this one.
Yeah, you could use the side of your calculator. Jacob. That's why it's the 99th percentile, not the 100th. All right, let's take this one step further. X is 0. What's the value of y? Josh? Nope. Aubrey? -1. 5/6 times 0 is 0. And then take away 1. -1. What if x is, 18? Say x is 18. What's the value of y going to be? Pat? No. Oh, gosh, no. 0 for 2. Strike 2. Oh? No? Angelina? 14 is correct. And we got 14 by doing 6 goes into 18 3 times. 3 times 5 is 15. Take away 1, you're at 14. What if I told you x was -12? What if I told you x was -12? What would y be? Paige. -11. That is the correct answer. Good job. 6 goes into -12, -2 times. -2 times 5 is -10. If you're at -10 and take away 1, you go back 1, you're at -11. Nice job. Now, where would you find all three of these points? Where would these points be? Ostrowski? Somewhere on this line. Somewhere on this line. And what's the distance from this point to this point? What's the change from this point to this point? Alyssa? 5/6. And what's the change from these points to these points? Zerar? 5/6. If I take this point right here, and I take this point right here, and you have no idea what the coordinates are, what's the slope there? What's the rise over run? What's the change in the vertical axis divided by the change in the horizontal axis? Bree? 5/6. 5/6. Kylie? Because that's what the slope is. And like I said in the first example, no matter what point you go from, if you go from point to point, it's -2. If you go from this point to that point, it's -2. If you go from this point to that point, it's -2. If I go from this point to this point, what's it going to be, Kylie? 5/6. Good job. All right, 2 more examples, and then we are done. So this linear function has an equation of y equals -5x plus a half. Where's our starting position, Renee? 1/2. It's right there. 1/2 is right in between 0 and 1. Hannah, what's our slope? And how do we write that as a unit rate? Good. Change in the vertical axis divided by the change in the horizontal axis. So if the change in the vertical axis is -5, Adriana, are we going to go up or down 5? 1, 2, 3, 4, 5. So you should be in between -4 and -5 right now. Our horizontal change is 1. Christina, are we going to go to the left or to the right? Which one? Why? Right. We're going to go to the right because it's a positive. Connect the dots. Oh, hand-eye coordination was a little off there, huh? That's not a very good line. I want you to take a look at something. Notice how this is a negative slope and it goes down. Negative slope, the line goes down. Positive slope goes up. Now look at how steep these are. There's a good chance I could ski down this hill. There's a good chance I would fall, roll, and become a huge snowball going all the way down this one. This hill is a lot steeper because the slope is bigger. 5 is bigger than 5/6. So it's much steeper. You guys see how much steeper this is than this one? I could coast down this one. Whether it would be on a sled, snowboard, or skis. I would feel comfortable. This one, not so much. Where's this line going to start? Where is this line going to pass through? What is the y-intercept? Jacob? No. Alyssa? 8. Remember that the slope is the number in front of x. Our unit rate is always the number in front of x. What's our slope here? Johnny?
8.
No, 8 is our y-intercept. That's why we plotted it. What's our slope? 0. There is no slope. There is no x. So if our slope is 0, how do we write that as a unit rate? Gerard?
0.
As a unit rate?
0. Over 0.
0 over 0. It's not a number. Can't have 0 over 0. Aubrey? 0 over 1. Our vertical change is 0. So am I going to go up or down? I'm not going anywhere. The change is 0. My horizontal change is 1. Positive 1. So do I go to the left or do I go to the right? Christina. And now connect the dots. And notice, we have a horizontal line. It's flat. Why is it flat? Because there's no slope. There's no incline. There's no decline. There's no increase or decrease. Nothing is ascending. Nothing is descending. It's 0. It's flat. It's like walking into the classroom. It's like walking down the hallway. It's like walking across your kitchen floor to walk to the refrigerator. There's no incline, there's no decline. The slope is 0. Now, I gave you a couple examples of a 0 slope. Where in real life would we ever have a negative slope? Where would our unit rate, our slope, ever be negative, Paige? All right, if we're scuba diving, our location could be 5 meters below sea level. We could be dropping 5 meters per minute. Good example. Aaron? Taking money out of bank. I take $5 a day out of the bank. I withdraw $5 a day. Zach? All right. I pay the babysitter $5 an hour a day. That is correct. Where would we in real life ever have a positive slope? Hannah?
Getting paid at a job.
Getting paid at a job. Yeah, I get $500 a week. I don't. I wish. But, you know, it'd be nice. Jason?
Depositing money in a bank.
Depositing money in a bank. Strowski? Do what? Going up a mountain. Maybe you're going 120 feet or 120 meters per day. Paige? Going up in an airplane. Your vehicle, car, van, truck, Volkswagen, when you accelerate. What about if you heat up water? Is that an example of a positive? Or is that negative? If I heat up water. Just trying to bring some science into this. It's positive. Because over time, as time increases, what happens to the temperature of water? It's going to rise. So for water, as temperature increases, or as time increases, the water temperature increases. And in fact, this is something, anybody ever make, what's it called with the noodles and cheese? Macaroni and cheese, thank you. As you make macaroni and cheese, you heat up the water. It gets warmer and warmer and warmer and hotter and hotter and hotter and hotter. And then all of a sudden, what does the water start to do? Does the temperature rise when water boils?
Yeah.
No. The water just boils. Water's boiling. Water's boiling. And then it starts to cool. And it starts to cool. And it starts to cool until it gets back to room temperature. That's what a graph of water boiling would look like. Now, is this a linear function? No. It's not linear. Okay? But I just wanted to give you an example of water heating up, water boiling, water cooling off. This is a great example of in real life where you have a positive slope, a zero slope, and a negative slope. All in one activity. Oh, we're not done yet. I still have 4 minutes. And I want to know something right now. And this is the problem we ended yesterday's class with. For number 4, what's the y-intercept? What's the y-intercept in number 4, Maddie? $200. So am I going to sit here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? What am I going to count by? I could count by tens. I could count by hundreds. I could count by 50s. I could count by 5s. I could count by 200s. I could count by 2s. I could count by 25s. We already said 50s. I could count by 4s. I could count by 20s. Does it matter? Is Mr. Meeks going to tell you which way to do it? No. So let's say that I decided to count by 50s. So there's my 200. My slope is 4. Therefore, my unit rate is 4 over 1. Am I going to go up 4 over 1? If my unit rate is 4, and I'm counting by increments of 50, 4 over 1 is equivalent to how many 50ths? Timmy? 200. So my rise, my vertical change is 200, 50, 100, 150, 200. And my horizontal change is 50. Tomorrow, this is what I'm going to hammer you with. When our y-intercept is big and we have to go by different intervals, increments.